We're going to go to example number 3. I'm going to bypass number 2. It's a similar um, problem to number 1. They give us an equation. We take the derivative. We substitute the time, the instant that they want, which is time 5, and then we get an answer, right? So I think we should be okay. But I'd rather look at number 3. Number 3 offers us an interesting situation here. The rumor is spreading around school that Mr. Passwater once placed third in the world's strongest man contest. The rumor is spreading at the rate of drdt equals 1/4 r times the quantity 500 minus r, where r of t is the total number of students that have heard the rumor, and t is the number of hours since the rumor began. Is the rumor spreading faster when 200 people have heard it or when 400 people have heard it? And explain your reasoning. Okay, so, this is a little bit different. It's asking about, is the rumor spreading faster? So that means I need to know the rate at which the rumor is spreading. But that's what we're given. We're given the derivative, which is the rate at which the rumor is spreading. So if I'm trying to compare at which point was the rumor spreading faster, then why don't I figure out what is the rate when 200 people have heard it and what is the rate when 400 people have heard it, and we just compare. So we can say dr dt evaluated when r is 200, when the number of people that have heard the rumor is 200. According to this formula, that would be 1/4 times 200 times 500 minus 200. And then I'm going to find the rate at which the rumor is spreading by evaluating at 400, when 400 people have heard it. So this would be 1/4 times 400 times 500 minus 400. Because I already know that the rate of change, drdt, is the number of students per hour. How do I know that? Because I know that r of t is the total number of students. So whatever answer I get here, that's the number of students. But my input variable, which is t, stands for time, and the time measurement, they tell me, is in hours. So this is per hour. So whatever answer I get here, I already have the rate for 200 people and the rate for 400 people. So let's do this really quick here. 1/4 of 200. What's 1/4 of 200? 50 times 500 minus 200, that's 300. So this would be, is that right? 300? Yes. So then this would be 15,000 number of students per hour, or students per hour. I guess I can just say students per hour. I don't need the word number. And then the other one, this is, let's see, 1/4 times 400, that's 100, times, and subtract these, and you get 100. And if you multiply those, that's 1 with 4 zeros. And it's 10,000 students per hour. That's how fast the rumor's spreading. And when I compare these, the faster rate would definitely be here. So we can say that the rumor spreading faster, and I guess I'll write it down. The rumor is spreading faster when 200 people have heard it. One of the things that we'll talk about as we start looking at free response questions is you should always answer the question. You can show your work. The work might might and usually does count as justification, but ultimately you need to make sure you answer the question. The question was, is the rumor spreading faster when 2 people have heard it or when 400 people have heard it? So here is the answer to that question. But this is the comparison of the two rates, which is the justification or the explanation of your answer. But there you go. That would be number 3.